students. Today we're going to finish the functional groups, which are on Table R. We're going to be looking at organic acids, esters, and amines and amides. All right, let's get started.
All right, we're going to start with organic acids. This has what we call our carboxyl group, which is a combination of the carbonyl group, so the C or carbon double bonded to oxygen, and a hydroxyl group, which is the OH group. So it has both of them, and as you can see, they're actually at the end of a chain. So we're going to use that to help us identify organic acids. Now for organic acids, remember an acid is an electrolyte. The carboxyl group is always at the end of the compound, so it's always on that first or primary compound. Also note that the shorter the attached hydrocarbon chain, the stronger the acid. So when we go to name organic acids, we always want to use the suffix oic acid. And again, with organic acids, because it's always on the end of a chain or on the primary carbon, we don't have to use any numbers. So here we have an example of organic acid. I'm going to first name my carbon chain. So I have 2 carbons, which is the prefix eth. So then I'm going to put, basically I'm writing ethane and I'm just taking off the E. Then, because of my functional group, so that double bonded oxygen and the OH group on the same carbon is going to indicate the organic acid, which means that that's how I'm going to end or have the suffix as. So ethanoic acid. All right, let's go the other way. Here we have pentanoic acid. I'm going to start with my carbon chain. So pent is 5 carbons, so I have 5 carbons there. And then I'm going to add on my functional group. So since I have an organic acid on one of the ends, I'm going to put a double bonded oxygen and an OH group. I could have put it on this carbon over on the left. I'm just kind of in the habit of just placing it on the right when I'm drawing it, but you can put it on the left. And then you carefully add in the hydrogens. Just make sure this carbon that's attached to the oxygen and OH group doesn't have any extra hydrogens on it because it's already reached its limit of the 4 bonds around it. All right, moving on to esters. I find this is one of the trickier ones for students to name, so definitely take your time going through this. These have 2 oxygens that are actually at the middle of a chain, and it's surrounded by 2 different alkyl groups. These actually have a very nice odor, so you tend to notice them when we're doing a lab because they have a very sweet smell. When we go to name esters, there's going to be 2 main parts that we're going to look at. We first want to write the name of the alkyl groups that's directly attached to the oxygen side. So here's my oxygen that's in the middle of the chain, so the one to the side of it that's directly attached to it, I'm going to name first. Then I'm going to name the carbon chain or the alkyl group that's attached to basically both oxygens here, and really I should have this circle going around that carbon too, so we're going to include that in our chain. And then finally we're going to add the suffix O8 to it. Alright, so let's take a look at some examples. Here we have our picture. We're going to write the name. So I'm first going to name the carbon chain that's attached directly to the oxygen. And it's basically not having anything to do with that double bonded oxygen on this carbon. So there I have 1 carbon, so that's going to be my methyl group. And then I'm going to look at the chain of carbon that's attached to both oxygens. So it's counting the carbon that's tied to both of them, I have 1, 2, 3. So that's where I have my prop prefix, and that's how I'm going to end it as well with the O8. So I have methyl, propan, O8. Excuse me. All right, so here we have a name, and we're going to, and I've color-coded it just so you can see the different parts of how I'm going to draw this. So I'm actually going to start with the butane part. So I have my 4 carbons. And now I'm going to add on the O8. So this is telling me that I have an ester. So I want to show the double bonded oxygen along with the other single oxygen. Okay. And then finally I'm going to add the last part, which is on the other side of my oxygen. So I have 3 carbons on that side. So I kind of go backwards when I'm going from the name to the drawing, just because it's a little bit easier for me personally to fill it in. But you can always start with the propyl and work backwards. All right, and then I'm going to carefully again fill in my hydrogens, being careful that I don't place any hydrogens on this carbon because it's already been or reached its maximum of 4. And you should also see that oxygen only has 2 each. All right, moving right along to amines. An amine is a hydrocarbon in which 1 or more hydrogens are replaced, I shouldn't say replaced by an amino group NH2. And we're going to simply use the suffix amine, which is easy to remember. So these, we're going to kind of keep them more simpler. These can get pretty tricky to name, but we're going to for the most part, keep it simple. So here you're going to see that I have an amine because I have a nitrogen. The carbon is either attached to other carbons and hydrogens, and we tend to do these ones with NH2. However, other things can be attached instead of these hydrogens, but we won't worry about that for right now. All right, so let's start. We have one carbon, okay, that's attached to the nitrogen, so that's simply going to be then methanamine. All right, so again, all I had to take care of was this CH3 group that's attached to my amine. Going backwards, here's going to be a little bit trickier because I have a larger carbon chain. So I'm going to start with that. Prop indicates 3 carbons, so I'm going to draw the 3. This 2 is showing me where that NH2 group is. So I'm going to have it off of my second carbon, and then the amine is going to be my NH2 group. So again, the prop part is my 3 carbons. The 2 is showing me where my NH2 is, which is off of my second carbon. And then I'm going to carefully fill in the hydrogens, and oops, if you notice I'm missing one right here, so make sure you fill that into your notes, that hydrogen coming off of that middle carbon so that it has 4 bonds. Amides are similar, but if you look in the picture you can see that while it does have the N group like we had before, it also has a carbon with a double bonded oxygen. So that's how you can tell the difference between an amine and an amide. So here we're going to look at, we have again our NH2 group coming off of a carbon, however that same carbon has a double bonded oxygen. So we're going to fill in our 3 carbons, and we're going to also add in the ending amide since I have that as my functional group. So it's propanamide. And again, the prop part came from the 3 carbons. The amide is the significance of this functional group with the double bonded oxygen and the NH2. And again, check out table R so you can see how to relate these functional groups to that. All right, going in the opposite direction, I'm going to start with my carbon chain. So I have 4 carbons. But stands for the 4. And then my amide group, I'm going to fill in on one of the N carbons. I'm going to fill in the double bonded oxygen along with the NH2 group, and then I'm going to carefully place the rest of my hydrogens. All right, and then finally, just so you know, amino acids is related to this. This is an organic acid that contains 1 or more amino groups. And you can kind of sketch this out, and you can see here I have an amino group, NH2, and then I have what we call a carboxylic acid group. And then this carbon connecting them, we can have side chains and that type of thing. These are important because they're the building blocks of proteins. I'm sure you talked a lot about this last year in biology. All right, one thing I just want to point out is these different functional groups can be isomers of each other. Alcohols and ethers both have 1 oxygen. They would have the same molecular formulas, different structural. Organic acids and esters are also isomers of each other. They both share carboxyl groups, which is the COO. And finally, aldehydes and ketones both share the carbonyl group, which is the carbon double bonded to the oxygen. And here's some examples. So you can see they have the same, you don't need to draw this all down, they have the same molecular formula, but they have different structures. So those are isomers of each other. All right, well that's it. We only have one more video after this lesson, so we are almost there.